Hi everyone, my name is Christian, and the next session will be a sponsor talk. This is coming from one of our supporter sponsors, Optiver. I am certain that you know the company, but if not, for sure the speaker will let us know a little bit more. So the next speaker is Leanne Fok, and the title of the talk is Infrastructure as Code in a Latency-Critical Bare Metal World. Sounds very critical and interesting, so I hope you enjoy the session.
Hi there. Thanks for coming to this talk about infrastructure as code in a latency-critical bare metal world. My name's Leanne Fok, and today I'll talk to you about some of the challenges we've faced deploying and managing Optiver's infrastructure across the globe. Quick about me. So I'm a senior infrastructure engineer at Optiver Amsterdam. I've been here for about 15 years, working across various roles and teams. More recently, I led the infrastructure platform team, which builds and manages our infrastructure as code stack. And right now I'm working on our new container orchestration system. I was born in Hong Kong. I grew up in Australia and I moved to the Netherlands. I thought that I would stay for a couple of years, but I loved it so much that I'm still here many years later. Lifestyle is a definite major pro here. I definitely recommend it. I have a background in computer science, and before joining Optiver, I worked in a couple of tech companies and an investment bank. Outside of work, I love rock climbing, I love cycling, singing and playing instruments. I also spend a lot of time thinking about food, probably a bit too much. I love to eat delicious things and I'll go far out of my way to make that happen, as you can see from the picture. So setting the scene for this talk. Optiver is a global trading firm with offices around the world. We trade and provide liquidity across many different financial exchanges, and this is an industry where nanoseconds matter, and increasingly picoseconds as well. So our ability to get information and respond to it faster than others is critical to our business. In our most competitive markets, even a few centimetres of cable can make a big difference. That can mean a server executing profitable trades or one that's consistently failing. So when precision matters this much, you can imagine that we want as much control as possible over our physical infrastructure. And to achieve that, we co-locate our trading infrastructure as close to the exchange as possible, which is quite often actually a room right next to the exchange, and we manage it from the ground up, literally. So say that we want to trade in a new market. There's a large number of steps that need to happen before we can actually do that. Some of the things we need to think about. So deciding on the desired footprint. How much trading do we expect to do here? How much growth do we expect over time? So once we've decided that, we need to actually acquire physical space. We need to negotiate contracts with vendors. We need to choose and order all the servers and network switches that we're going to need, also the different racks that we'll use. We need to organise connectivity between this co-location and our data centres. There's power requirements to plan, redundancy considerations to make. So the list goes on, and you can see that there's a lot of different aspects that we need to manage. So what did infrastructure management look like historically? You can think about the last time that you started using a new computer or a new laptop. There's quite a few steps that you have to go through to set it up. So most of these things you'll do manually. You'll connect to your networks, you'll get your peripherals working, you'll install all of your applications, tweak all your settings and update your wallpaper to your favourite K-pop Demon Hunters image, though that might just be me. There's a lot of manual steps and you always forget something during your first run through and you end up having to fix it again later. So that sort of process is exactly how we used to manage our servers and network switches, only with much higher stakes. A single mistake could affect the entire trading system, and every machine was set up a bit differently depending on who installed it, when they did it, what was happening around that time. So a logical next step to this can be to use a tool like Ansible to convert the list of manual steps into playbooks. This helps a lot, but it's still imperative and requires both end users and infrastructure to understand a lot of low-level detail. And this is where the concepts of IAC come in. So what is IAC and how can it help us manage these complexities? In practice, IAC means that we manage infrastructure using code rather than manual processes. So we write code that describes the desired state of our systems rather than executing manual processes. We commit that code to Git. We use the same developer workflows that a lot of people will be familiar with: pull requests, tests, reviews. So once we've had reviews and PRs are approved, we'll merge that, and automation will apply that code to make the real infrastructure match the intent. So our servers, networks, and configs become declarative artifacts. We declare what we want that end state of our infrastructure to look like, rather than having to maintain a list of manual steps and leak this towards the users. So why the emphasis on declarative? What does it give you that an imperative flow does not? So a declarative definition allows for clarity of intent. You define your desired end state without needing to think about the provisioning process. This makes your configs easier to read, reason about, and maintain. You also have this in your PRs, so you'll actually get versioning for free as well. There's less state handling for the end user. The provisioning system will manage the steps and dependencies, which the end user doesn't need to be aware of. And declarative definitions give you idempotence. This means that reapplying the same config over and over will always converge to the same desired end state, or rolling back to a previous config will also give you the same thing as the first time you ran that. This means that you have consistency and repeatability. So a critical part of the declarative IAC is the reconciliation loop. User-declared desired state will be regularly compared to the observed current state, and that loop will notify or take action automatically if deviations are found. This is a big part of building trust in your system. If you've worked with something like Argo CD for managing Kubernetes applications, you'll be familiar with this type of loop, and it's a common pattern across multiple parts of the tech industry. So what does this look like in the cloud? You've likely seen something similar to this if you've spun up an AWS EC2 instance. You declare that you want a server, you specify its instance type, and AWS takes care of making it real. You don't say how it should happen, nor should you have to care. So you declare your intent, and the cloud provider takes care of turning this into reality. So our challenge as Optiver is that we can't use the cloud. We need full physical control over our environment, and the latency of a cloud setup wouldn't be acceptable. But we still want to have the same benefits. We want consistency, we want reproducibility, we want version control and reviews, all the things that a PR will give you. And most importantly, we want trust in our infrastructure. We want trust and confidence that our infrastructure looks the way that we expect. So the question becomes, how do we build our own cloud platform with all those benefits, but for bare metal? So before you write a line of code, you want to define standards for each part of your infrastructure that you want to model. We'll use a physical example to illustrate the point here, but it will apply equally to logical configs like network routing, VLAN setups, etc. So in this picture, you can see that we've got 9 physical 1RU servers. For each server, we need to have 2 power cords patched to redundant power sources. We need terminal server connections, and we need 4 network connections to the various physical switches at the top of the rack. So just this small list of requirements opens up a lot of possible variation. If you asked 4 different data center engineers to answer these questions, you'd no doubt end up with a lot of different designs. Some example trade-offs to consider with type of cable are copper DAC cables versus optical fibers. DAC cables are less prone to errors, but they're also thicker. They're a bit harder to maneuver in a small space, and you have shorter effective range when compared to optical fiber. Maybe you decide that you want to have a different color for each of your cable functions, but be aware that this means that you have to keep extra stock of all of these in all your data centers, including the different length cables for servers that are further away. Each engineer is likely to have their own preference for how they physically route cables to create their own ideal cable management setup, and we haven't even started to talk about how we should actually decide to map each server network port to the various network switch ports. There's a lot of different standards to define, and here are some of the examples, like naming schemes, server hardware profiles, OS versions. There's quite a bit that we have to take care of. So what are some of the benefits of defining standards? Having an agreed upon standard allows for faster troubleshooting. You can see a host name come up with an error and immediately know if that thing is prod or dev. Maybe you agree on a small list of standard machine profiles that allow you to more easily keep stock and therefore fulfill user requests faster. It allows you to reason about your environment more easily as well. For example, knowing that your standard physical servers all have access to the data network allows you to put something in the data network and know that you can access everything without needing to do manual checks first. Onboarding new people is also much easier when you can teach them 90% of your environment just by explaining the standards. And the biggest reason for this in the context of this talk is to allow for automation. Let's say that your file system layouts were different on all of your machines. You wouldn't be able to reliably install your operating system and end up wasting time on low-value tasks. This is not to say that standards are an easy thing to define, like far from it actually, and a lot of this will be conversations with users of your system who are used to having a lot of options. But more flexibility usually means less speed and greater potential errors, and you have to strike a good balance based on your company's priorities. A good standard should allow for some exceptions, but still model them in your intent to ensure that your reconciliation loop is still doing its job of maintaining trust. So let's come back to our trading co-location that we want to manage using infrastructure as code and discuss the different pieces that we've built inside of Optiver. So the first thing we want is our intent system, where we're going to model what our infrastructure looks like. This is written in Django with a Postgres database, and it models the devices, concepts, and relationships that we care about. Devices like server, switch, component items like network interface, concepts like patch, which will represent a cable between two network interfaces. We then add an API on top of this using Django REST framework on top of our models, and this can be used to programmatically read or write to our database. So we now have enough to actually start to add in our provisioning pipelines. These are decoupled from intent and can be swapped and replaced at will. So these will read from Intent's API, work out what they need to do to configure the devices in the trading co-location. This could be something like using Napalm, which is a Python library that allows you to log in and configure switches. Or it could be running an Ansible playbook that reads from intent and brings up the new server interfaces that you expect and applies IPs. So now we have something reading intent and deploying this to the trading co-location. So the next thing we want to do is to start to build our reconciliation loop. This is where the concept of truth can be added. In our case, this also consists of database models representing the infrastructure and an API for programmatic access. But the data written here is written by independent truth collectors that scrape real device state from the trading locations and inserts this into the truth database. So now we have a copy of intent and truth, and we can add audits. So this will actually sit in between these two databases and will let you know when these two things deviate in some way. From a coding perspective, this is like the tests you write to assert a function's behavior. We write audits to assert that the provisioning lines are doing what they say they'll do. So a quick sidestep briefly to give you a bit of detail on the realities of the project strategy. We like to use the analogy that we were rebuilding the boat while we were still rowing it. So I showed the reconciliation loop earlier, which checks truth and intent and leads to action if these two things deviated. The reality is that we needed to implement our new stack with a large existing infra, with a lot of existing processes that engineers were used to using, and we didn't have the resources to support all the concepts in the whole loop immediately. So our general strategy when onboarding a new concept was to prioritize building a truth collector first, populating the intent desired state, and adding the audits to make the discrepancies visible. So we were intentionally ignoring the provisioning piece initially, but this still allowed us to build trust with the engineers because they could immediately see when their truth deviated from their intent, and they could use whatever their existing provisioning strategies allowed them to do. So coming back to fill out the rest of this picture, for quite some time we had custom CLI tools that engineers would use to talk to the intent APIs to make updates, but we're now closing the ISC loop with our intent Terraform provider written in Go, which translates Terraform's declarative definitions into intent API calls. And so engineers now mainly interact with our intent Terraform repo to make changes to the infrastructure. This defines our standards in Terraform modules and hides most of these low-level details away from the user. A quick example, if we were to add 2 new standard servers to our existing rack, an engineer would create a PR to add those 2 new servers in Terraform, just giving the physical attributes of that particular server. Terraform will apply and take the new assets, apply the standards, create all the other relationships in intent. I won't read all of that out because I'm running out of time. We can output patch instructions using the cable and SFP standards. We can rack and patch the server, ready for OS install. And the audits will immediately tell us if something is actually incorrectly patched or the system is not set up correctly. So some quick closing thoughts. Good infrastructure as code isn't dependent on any specific tools or language. You can build what fits best in your environment. What it does depend on is clarity of intent and trust in automation, building the loops that build confidence in your system. This is definitely one of those projects that can help you sleep better at night. Even if you don't manage infrastructure, you likely have some areas that can benefit from some of the general IAC lessons. Agreed pragmatic standards can lead to less wasted time. Maybe that's something as simple as a standardized template for your user requests. Regular integrity checks can help maintain trust. Maybe that's adding more tests to a critical code base or doing a more regular review and cleanup of your own to-do list. And that's all I've got for today. Thanks for your time. I'll be on Discord after this if you want to chat about Optiver, IAC, or good food. Cheers.
I hope you liked the talk. I am certain that Leanne will be more than happy to answer all your questions in Discord. So remember, you can go and drop by all of those into the Optiver channel. And you remember, you can ask both about the content of the talk, but also some questions that you might have about Optiver. So I hope you keep enjoying the conference. See you around.